Question 5. A golf ball is at rest at point A on horizontal ground. The ball is hit and initially moves at angle alpha to the ground. The ball first hits the ground at point B, where AB is 120 meters, as shown in figure 3. The motion of the ball is modelled as that of a particle moving freely under gravity, whose initial speed is u meters per second. Using this model, part A, show that u squared sine alpha cos alpha is equal to 588. Well, with projectile questions, we are typically looking to resolve forces vertically and horizontally. And since we're looking vertically and horizontally, we want to break down this initial component of speed into its vertical and horizontal components. So its initial speed was u at an angle of alpha, which means its vertical component of speed is u sine alpha acting upwards, and its horizontal component of speed is u cos alpha. Let's start by looking up and down, and I'm going to take up to be the positive forces here. Whenever we're looking up and down on a projectile question, we are looking at SUVAT. And the reason we're looking at SUVAT is because we have an acceleration in projectile questions vertically, and that is because we have the acceleration due to gravity. So labeling what we have here on SUVAT, I know the displacement, S, is going to be 0 because this particle vertically is starting and finishing at the same point in the vertical plane. Its initial speed vertically is u sine alpha. I don't know the speed at which it hits the ground. I do know the acceleration is due to gravity, and so that will be g. It is negative in this case because I've taken up to be the positive direction. Gravity, of course, works towards the ground. Now, I don't know t. However, I can find t if I now choose to look horizontally. Now, resolving horizontally, we're going to be using our good old speed, distance, time formula back from GCSE. And the reason we can use speed, distance, time when we're looking horizontally, because we consider there to be no acceleration when we are looking horizontally, left and right, on a projectiles question. And since there is no acceleration, the equation we have is speed, distance, time. Now, from the speed, distance, time triangle, time then is equal to the distance divided by the speed. And so the time that we want, our capital T, is the distance horizontally, that's 120, divided by the speed, and the horizontal component of speed is u cos alpha. So I have a t here I can put into my SUVAT components, and so now I have 4 components, s, u, a and t. I don't need v in this case, and so I can use the equation s equals ut plus half at squared. Substituting in the values I have. Got to be very careful here because there's lots of complex components. So I've got s with 0 is equal to ut, so that's u sine alpha multiplied by my t value, 120 over u cos alpha, and that's plus half a is negative g, t squared, and my t is 120 over u cos alpha. So first thing I'm going to do, I'm going to divide by u here. I'm going to cancel those in this component. So it's 120 sine alpha over cos alpha. And here I'm just going to simplify this part here. So negative g over 2, when I do a half times negative g. And I have squared this component. So 120 squared is 14,400. And u cos alpha squared is u squared cos squared alpha. I can now write this as 120 sine alpha over cos alpha is equal to, so by adding this component and just switching them round, I have divided the 14,400 by 2, which is 7,200g over u squared cos squared alpha. So starting at this point here, I'm now going to multiply this 7,200 by 9.8 and divide it by 120, and lo and behold, we get our 588, which is just as well, because we would be pretty stuck without it. Now we can see I've got 588 over u squared cos squared alpha on the right hand side. I just want the 588, so let's multiply up through by the u squared cos squared alpha, so multiplying both sides by u squared cos squared alpha. On the left, 1 cos alpha will cancel to leave me with u squared sine alpha cos alpha, and on the right I'll have 588, which is what I wanted to show. Perfect. Part B. The ball reaches a maximum height of 10 meters above the ground. Show that u squared is equal to 1960. So we are looking at maximum height here, so it would make sense to resolve vertically. And again, I'm going to take upwards to be positive. And when we're looking vertically on projectiles, we're considering SUVAT. Now, this time I know S to be my maximum height, and I'm told that's 10. The vertical component of speed is the same, my u sine alpha. The velocity at the peak of height is actually 0. So this is one thing to remember. At the maximum height that a ball can reach, the velocity is actually 0, because what's going to happen is the velocity is going to change direction at this point. So after it's finished going up, it's eventually going to come down. My acceleration, still due to gravity, is going to be negative g, and I don't need the time necessarily in this case, because I have v squared is equal to u squared plus 2as as my SUVAT equation. I can substitute in the values I've got, so my v is 0, and that's equal to u squared, so that's u squared sine squared alpha, 2as, so minus 20g. And just to make this look a little bit neater, I'm going to write it as u squared sine squared alpha is equal to 20 times 9.8, which is 196. Now, this is where we've got a sine squared that I don't want. I don't want this sine squared, but I have already written an equation with a u squared from part A. So let's bring that back over here. And if I label these equations, 1 and 2, I can divide one through by the other. And the reason I want to do this is because I need to be able to substitute some values for sine alpha and cos alpha in order to have u squared by itself. And by considering these two equations, I can cancel the u squareds if I divide them by each other, and I can find a value for sine alpha or cos alpha. So if I do divide this equation through by this equation, the u squareds will cancel, and I will be left with sine over cos, which is tan alpha, and that will be equal to 1/3. Now, using my calculator, I can work from tan is equal to 1/3, and actually I could find a value here for this sine squared alpha. So let's do that on our calculator. And so I have tan alpha equal to 1/3. So if I put 1/3 on my calculator here, if I do the inverse tan function for that third, I can find my value of alpha, and I can now sine that value. So this is my value for sine alpha, which doesn't look too nice, but actually if I square that, I get a nice lovely 10th, which I can use very nicely in my equations. So we've seen sine squared alpha can be written as 1/10, and if sine squared alpha is 1/10, this equation 1 can be written as u squared times 1/10 is equal to 196. And so if we multiply by 10, u squared is indeed equal to 1960, which is what we wanted again. In a refinement to the model, the effect of air resistance is included. The motion of the ball from A to B is now modelled as that of a particle whose initial speed is v meters per second. This refined model is used to calculate a value for v. State which is greater, u or v, giving a reason for your answer. Well, if this model is going to be refined, and the only change we're making is the speed, that means the distance it travels is the same. And if this ball is going to travel the same distance, but now under the threat of air resistance, that v will need to be greater, because it will need to overcome air resistance. So v will be greater, as it has to overcome air resistance. Part D, state one further refinement to the model that would make the model more realistic. A good concept for these types of questions is to look for something that's been modelled in the question that we could do differently. So if we look here, the motion of the ball is modelled as a particle. Now, if the ball was not modelled as a particle, the question would indeed be more realistic, as it would involve spinning and all sorts of other crazy things. And so the ball could not be modelled as a particle is a good refinement that would make this more realistic.